Okay. Let's see. Alright, well, hello there everyone. So today we'll be working some more on the hardware abstractions. So let's take a look what we have. Stream's still good? Yep, looks fine to me. Okay, let me just switch to the pros profile. Oh, do I not have a pros profile? Or maybe I just have it on default. Yep, it's just all in defaults. Okay, cool. Well, let me just check. Yep, okay, my mic's a bit loud. Hold on. Okay, this should be better. This should be about right, yeah. Okay, so motor abstractions. Last time we figured out that we can't separate the motor encoders from the motor objects because that would cause the API to, well, be a lot more complicated if you wanted to do something like a PDO. And that defeats the whole purpose of v0.6. Well, that defeats. Well, basically, we want that to be easy in v0.6. So, yeah. Oh, it's the stable branch. Right, I was like, what? Okay. Yeah, we want to go to master branch. Actually, no, we don't even want to look at LemLib. I forgot, this is a completely different repository. Alright, that's better. Let's see. So we got, yeah, I think the motor stuff is already finished. Yeah, it looks pretty finished to me. So then we want to move on. Yeah, let's check the IMU and see how that's doing. Okay, so calibrate. Yes, we have that. Is calibrated? Yes, we have that. We have is calibrating as well. Is connected. We have get rotation. Let's take a look here. Yep, that looks good. And set rotation. Yeah, that also looks good. Okay, so I guess IMU is done. So encoder done. We have the ADI encoder. We have the V5 rotation sensor. That all looks good. So you know what? I think the hardware repository is done. Okay then, then we have to get this merged into the master branch. I'm gonna bump the version. Let me see if I actually made a release for hardware yet. I don't think I have. Nope. No new releases. But I guess we do need to update the README. Okay, I think we'll leave the V5 GPS sensor alone for now, because I haven't heard of a single person who was successful in using it. And I don't know if its heading is also updated by the GPS field strip. I suspect it is, so yeah, I think we're just gonna leave that. Right. What? Why is it saying I never logged in here? Alright. Alright, let's make a new release. I'm just gonna copy the layout of a LemLib release. Okay, yeah, so just got a small introduction and then let's get down to installation. I don't think we have a depot set up quite yet. And I will see. Okay, we'll leave installation blank for now, and then after we see if we have like the depot workflow installed or not, we'll see about that installation thing. Let's close these issues or get them sorted now, and then release v0.2. Okay, this one we might have to implement. Okay, add the option to change the output velocity of the motor group class. Okay, the only way the output velocity of the motor group would change during runtime is because of a multi-speed transmission. While this mechanism is rare, it has the potential to make an appearance during the late season of 2024-2025. The motor group class should automatically handle this. Alright, we'll leave that one for now. Oh, wait, hold on. Did I not close this? Okay, there we go. Okay. Motor temperature telemetry. Okay, we want temperature motor color get temperature. Okay. Let's get that done. Oh yeah, Pros recently got a update to the Vex SDK version they're using, which means we can actually have the get type function not be like weird and do cartridge shenanigans in order to figure out what motor is connected or not. Is this not a thing in the Unis template? Oh yes it is, we just gotta include it though, okay. Actually, I'm gonna copy a different doc comment because this one could return some errors. Just want to see how I deal with errors again. Okay, on failure setting error now. Okay, that's how we say it failed. Infinity on failure setting error now. Oh well, I haven't looked at units in a while. How do I convert stuff between to like an actual like float? Okay, I think it's like 2. I don't know what the API is for temperature. Let me take a look. Alright. I think internally they use Celsius. Actually, wait, what am I doing? We don't have to deal with this at all. Actually, no, we do, because the example code needs it. Actually, we should probably do some error checking in the example. Wait, is Celsius capitalized? Okay, not here. Okay. Alright, that's our example code. Let's get that implemented. Alright, yeah. Oops. Auto formatting can be a bit of a pain sometimes. Maybe I still haven't gotten used to it doing that even after using it for like a year. Right, gets the temperature Celsius, and it returns double, so it'll return infinity if it's not happy. Okay. So that means we can just straight up do and why is this not happy? Right. It also means I have to do the namespace thing here. For some reason it's perfectly fine not prefacing temperature here with the unit's namespace. Weird. Alright, well let's get temperature implemented. Just gonna copy this so we can implement it for the motor group as well. Alright, we'll implement the telemetry, the temperature right here. I think we already have the function signature fleshed out here. We do. Alright, there we go. Hold on, I thought I just got rid of the copy of the doc I made for the regular motor to get temperature. Right, yeah. So you're seeing some of the motor. Just need to change it a little bit. I think that's the syntax for yeah, I think that's the syntax for I think it's called is it range-based indexing? I don't know. It's more like iterating. Okay, that should be good for the header. We have it before get size, okay. Okay. So this could be pretty much just the same thing as what we have in motors, except if temperature. Actually, no. I think we do return infinity temperatures that are infinity. Let me just check that real quick. I want to see what happens when we get stuff like. Actually, yeah, we'll just return infinity. We'll just return whatever the regular motor temperature thing. Yeah, we'll just if a motor returns infinity, that same motor will also return infinity in this vector here. Oh, there's my first mistake. Why is this not happy? Oh, wait, I see. Right. Don't actually store a vector of motors. I think that's because the motors don't play nice with the regular vectors. I think. I'm not 100% sure. I'm certain I had a good reason to put that there. Honestly, I might actually just interact with the Probe C API, because if you have the port, it might honestly just be easier. Actually, does this return? What does this return? Double, okay. And what's, oh yeah, right, because this is just a raw flow, we need to convert it to a temperature. And why is it not happy? No known conversion from double to temperature. That is quite strange, because I would do the exact same thing in a regular motor. Oh, right, it's from Celsius. There we go. So, in case you're wondering, we return a vector of temperatures here, because just getting the average isn't as useful as getting the temperature as all of them, because you might have one overheating motor in a motor group, but then all the other motors are reading like 30 degrees, So then when you get the average, it's only like 40 degrees, and you're like, oh, okay, that's fine. But in reality, well, some of the motors are 30 degrees, and one of them is overheating. Alright, there we go. Alright, now we can close this issue. Let me just grab the commit hash that was implemented in. E28D038. Okay. I think that was the hash. I guess I'll see when I paste the link. Yep, it was. Cool. Alright, software motor offsets. Okay, so what this wants to do is it wants to store a row position in the motor group class, because, well, and the advantage of that is that basically it means that okay, so before we actually explain that, let's look at what would happen if we try to set the position of a motor encoder. So that set position function takes a float, right? So it's just a number with decimal points, but the motor encoder itself only supports setting, well, only supports like getting the angle and set increments, right? So when you try to set the angle, it'll actually just set it to the nearest like valid readout for the encoder. So if you try to set the motor to like a specific position, it's probably not going to set it to exactly that position. But with the software, by using software offsets instead of the VexOS offsets, this is no longer an issue. Now, fortunately, actually, I think we'll have to implement this for both the motor group and regular motors, because like yeah, I don't know, I think I'll have to take a look at that, like what's up with that STD pair of motor port and motor reversal, because that doesn't feel right to me. Well, let's get that implemented for the motor then. Alright, this is gonna be fun because the like get angle code is definitely the most complex stuff in the motor class. because we want it to not be affected if the user sets like the encoder units of the motor, or sets the position of the motor themselves. I don't think it's just into the latter, but it will be after this. Hold on. Let's think about this real quick. If it's software offset, then that means it's not going to be happy. Because in the motor group, because the offset data would be stored inside the motor group, inside the actual motor object and not the hardware. So, damn. That means we'll have to use we'll have to use a vector of LemLib motor objects in the motor group instead of the vector of ports and stuff. That's weird though. I don't know why we have that vector. I'm just gonna swap it out and see where it'll errors, and hopefully I'll see, oh, that's why we have it there somewhere. I want to take a look at that. Sorry, just give me one moment. I'll be right back. Alright, sorry, I'm back. Someone joined the disc. Actually, yeah, if someone joined the Discord call, just let me know. Okay. Right. We were going to software offsets, right? Alright, before I actually do that, I'm going to check if there's possible motor group side to get rid of the list of booleans, the list of pairs. Actually, before I do that, I've just thought of another improvement that we could make. Yeah, so basically when a motor disconnects, it's no longer powered, right? Now and since actually how the motor stores certain data, certain configuration, it's not stored on the brain side, which means we need to tell the motor, hey, I want you to use, okay, there's some stuff that still uses the same stuff, like cartridges are stored with XOS side, whether the motor is reversed or not is stored with XOS side, but stuff like encoder units, I think, are stored motor side. Now we're actually going to have to test what configurations are stored motor side. Let's see. Let's take a look at the pros docs and see how we can configure motors, because it might not even matter because we don't care about stuff like what encoder units the motor is set to, because it'll just adjust automatically. We want to look at the pros for stuff. Do they really add string literals to create motors? I guess they have. Alright. Brake mode is something. Voltage limit, I guess, as well. Oh, you know what? VexU users might want to VexU or VexI users will probably want to set motor current limits during runtime, or at least the advanced ones will. So I think we'll have to add that as well. Right, gearing. We'll have to find out whether that's stored VexOS side or motor side. Because if it's motor side, we will want to store that ourselves. So if the motor reconnects, if the motor reconnects, it won't lose that configuration. Voltage limit is definitely motor side. Well, actually, I'm not sure about that one either. We'll have to test. So basically, the ones we're interested in is the voltage limit and what was the other one? Brake mode. Voltage limit, brake mode. Okay. Reapply motor configuration on reconnect, or reconnection rather. Okay. I just want to take a look at the pro source code because I might already be doing this, or I know they at least talked about doing this because I remember the conversation. They really need to get they really need to fix all their branches because holy cow, they got so many. They also need to merge Develop Pros 4 into regular Develop because it's been main since May 19. Oh yeah, right, they updated the SDK. Alright. We want to take a look at the source and then the motor stuff. This will probably be handled on the C side. We'll take a look at both. Okay, it doesn't look like it's handled on the C side. Let's take a look at what happens on the C++ side. They all seem to fix their new lines, it's inconsistent. Nope, it is not handled on the C++ side either. So it'll be up to us to implement it. And this really is going to be the most optimal hardware abstractions in all of X. So much cool tech behind this stuff. Or rather, it has to be cool tech because of the failures on Pros and VexOS and just the overall design of the V5 as well. I'll do a video on the architecture of the V5. It's the goofiest thing ever. Okay, we'll talk about the implementation and then we'll talk about the limitations of this. Okay, so there are some problems with this, some limitations rather, or downsides. First downside is that we're going to have to check the motor configuration every single time a telemetry or another configuration function is run motor on the motor object side. Because if the the reason we have to do that and not just watch for configuration getters and setters motor, like motor side or motor class side rather, is because the users may interact with the Pros API to configure the motor on whatever port the motor is on. So if the motor is on port 2, we can have like the LemLib motor object on port 2 as well, but those private member variables like sort of the configuration won't be updated if the user updates the configuration on the pros API side. So we can sort of overcome this by checking the configuration of the motor every single time a member function is called on the LemLib motor object. But this is not ideal, but it's okay. What else? Oh yeah, I think we have automatic reconnection handled on the motor group side, but we're gonna have to handle that actual motor side now as well. And that's gonna be fun. Okay, and what else? No, I think that's about it. Actually, what we could do is we could tell the motor to reapply its configuration, reapply the stored configuration every time one of the member functions are run. But the problem with that is that the user will not be able to set the motor configuration by the pros API anymore. And I don't know if you want to do that. I don't think we do. So yeah, let's see if we have automatic reconnection stuff handled in the motor group. Whereas if you want reconnect handling, we need to store the previous, whether the motor was connected last time it checked, which you'll also have to check every single time. You know what? I am going to just send a DM, or not a DM, I'm just going to ask one of the Vex side people if it's possible to have like a callback if like a motor disconnects or not. Maybe there's like some Vex SDK function, and if anyone knows if there are, it's James Perriman and these guys. You know what? We might actually be able to always update the private member variables of the motor group. I saw this really cursed C thing you can do. I think it's called function hooks. And basically it'll run a function when you run another function. But that's specified during runtime, I think. Maybe it's during compile time, I don't know. But basically, if we could add function hooks to the Vex SDK. Actually, I don't know if that'll work because it's statically linked. No, we're just not going to do that because that's just too cursed. Actually, I'm going to post it in the LemLib Discord server instead in V5 Technical, and then I'll just ping I'll ping Tropical and see what he thinks. Actually, you know what? Let's check the public stuff, the public functions in the Vex SDK, because if it's not exposed in the Vex SDK anyway, then there isn't much of a point in using it, because then if we just interact with like the raw memory addresses, because it's not exposed, that would mean that LemLib could break if there's a VexOS update, and that's not acceptable. So I'd rather go with an inferior solution than have something unstable like that. So what I'm doing right now is I'm just installing the Vex, like the Vex code plugin, Vex code extension, because as you see, it downloads the SDK, and we can look at the headers of the SDK to see what type of stuff we have access to. And I'm pretty sure they store the path to the, yep, actually no, that's a toolchain path. We want the SDK path. Oh, right. It doesn't like the double backslash. I still can't believe Windows is using backslash. They really should switch to /. It's so annoying. Alright, so stuff we might want to look at is like generic device stuff and motor specific stuff. Nope, I don't see that. Actually, I do want to do that at the get motor type function, because that was something that was pretty damn annoying to do. Type. No, it doesn't seem they have, even though Perman said he would add it. But then again, Perman says a lot of stuff and never does it, so. But yeah, AI vision code, AI vision sensor stuff, so we can actually finally have that in pros. Although I don't know if they actually like added the made the neural networks for it yet to detect game objects. It's not going to be useful until they do. Otherwise, it's literally just a vision sensor that's very slightly better. But very slightly better than trash is still trash. Yep, does not seem like there's a way to do what I want to do. Very unfortunate. Still need to check if this is violating the. I don't want to see if this is on like the open marketplace, because if it is, I'm pretty sure it would be against rules, because this is not open source. So by letting them know, hey, this is breaking the rules, hopefully it'll get Perman to do what he says he'll do and make it open source. Okay. So it looks like we're on our own for detecting motor reconnects. Let's see if we handle it in the motor group. I think we do have a way of detecting that in the motor group. Let's take a look. It's so annoying that this stuff doesn't stay closed when you reopen the file. I might actually make a feature request for that in VS Code if there isn't one already. Oh, right, I see why we use these. So, yeah, ideally we would use a vector of LemLib motor objects, but this does not work if you want to remove an element from the vector, as the copy constructor is implicitly deleted. We do handle this, yes. So it has a bool for every port, and that represents whether the motor was connected or not the last time get angle was called. So it enables the motor group to properly handle a motor reconnect. Okay. Fantastic. But I think we're going to have to implement that motor side instead. Actually, we probably could just have it on both ends. Let me think. Alright, so a potential problem with this is at this configure. Well, actually, let's check what this configure motor implementation does, because I think it'll set the angle of the motor as well. Yes, it does. Oh yeah, I remember this thing was super annoying to implement because of because it needed to do the job of other functions, but those functions was called this, and you'd have an infinite loop, and the program would freeze. So yeah, that was a pain. Okay, so we're going to have to implement it on both sides because the motor group doesn't store a vector of LemLib motor objects. It just stores the ports instead. So, yeah, we're going to have to implement it on both sides, motor group and motor, and then it's not going to be there is a possibility that it's not going to be able to detect a reconnect. It'll only detect it if you're like calling it like every 10 milliseconds or so, or at least if it detected that the motor disconnected at some point, and it'll detect if the motor disconnected or not when you call get angle. We should actually update this so it calls it for every motor function, but I'm not 100% sure if that'll be possible or not. I'm dealing with this kind of crap. Really, really tempts me to switch to Vaxide, but I can't do that because no one knows how to use Vaxide, and also it's not stable enough yet. I'm just gonna tell them that. Well, I'm just gonna ask them whether they have like reconnect handling stuff like this. Alright, I'll let them know. And I'm also just gonna tell them again. I'm just gonna tell the pros people again. This is super annoying and should probably be handled. Well, no, not probably. This needs to be handled by the kernel. Let me check if there's an open issue for it. Oh, really? This is not a nice one. Still nothing from this one. Also nothing on this. Yeah, they better get their asses in gear pretty soon. Well, not better. I hope they do. There's just so much stuff that needs to be done pro side. Hold on. Okay. I already told them the sound is not necessary anymore. I don't know. I'll talk with Rocky. Oh, I got so annoyed with this that I actually made my own virtual file system. But luckily I don't deal with the SD card anymore, so. Alright, I'ma ask the pros people what's up. Or actually I'll just open a GitHub, open an issue on GitHub. That'll be the best way to do it. I'll leave that one out. Tend to be really critical of the Vex SDK and Vex OS. With good reason, but yeah. What this does need though is, actually, I don't know if motor cartridge is stored on board on Vex OS or motor hardware. We'll have to test. Actually, now I wonder, is it easier for me to implement this feature in LemLib, or is it easier for me to PR this into Pros? Damn. You know what? I think it might actually be easier just to PR this into Pros. But then the problem is it's never gonna get merged. Well, no, I'll just bully Rocky into merging it. Yeah. Rocky, if you're listening, I would never do such a thing. Okay. Should be stored by Pros. The motor as well as whether the motor was connected last cycle or not. If the motor was not connected last cycle but is during the current cycle, then the configuration the last saved configuration needs to be applied. Ideally, actually, this needs to happen on the C side of the Pros API, because otherwise, using C side stuff, using the C API would circumvent this feature. But that's annoying because well, we don't have object-oriented stuff in the C side. We'll have to actually store an array of structs, each of which contains the configuration of a motor on a specific port, I guess. So it'll have to be a static array of 21 structs, and then each element in that struct represents a motor that could be connected. So like on element 0 would represent the motor on port 1 if there is a motor, but they'd be a struct regardless of whether there's a motor connected or not. I'll ping pros people and get this sorted. Before the whole hotel incident, I talked to her, or talked to them about, I asked them why pros had both C and C++ API. And the reason for that was because pros 2, which was pros for the Cortex, which is the thing that was before the V5, which is like even a couple years before my time, and I started back in ChangeUp. Yeah, so Pros 2 was for the Cortex, and that was written entirely in C. There were people that hacked in C++ support for it, but it wasn't like official. So for Pros 3, they decided we're gonna write it in C, but we're gonna have C++ wrappers for it all. And I asked Pros what that was. I asked the hotel what that was, and yeah, they said that it's basically, it seemed like a good idea at the time, but if they went back and could make the same decision, they'd redo it in C++ and not do it in C. But it's too late for that now. That's kind of why Backside is so cool, because it's like Pros. It's like entirely from the ground up, arguably even more so, because Pros at least has like the vendor Vex SDK via Vex, but Vexside just skips that altogether and accesses the Vex SDK that's stored on the brain by finding where all the functions finding the memory addresses of all like the API in it, and that's really cool but also a bit cheeky. Okay. But yeah, so ideally this would be implemented on the C side of the Pros kernel. So this feature still works if motors are configured using the C API. This would require a static array of 21 structs for each of the 21 ports on the brain. Actually, see, we could use a dynamic array, but I mean, the thing is, this is going to be stored in the cold package anyway, and the V5 has so much flash memory. It's not even funny. Let's take a look. Text V5 brain. Let's see how much flash it has. I think it's 128 megs. It's only 32 megs. That can't be right. The Pros kernel is like 20, or maybe, oh, is it like 40? Let's take a look. That cannot be right, because I think the Pros kernel itself is more than that. No, it's only about 6,000. So that's about 6 megs. And what's LemLib like? I know the zip file got ridiculously big after we split off the motion stuff. We still need to figure out linker time optimization. That'll fix it right up. Yeah, I mean, we've got a firmware, and then right, LemLib's not there. I'm just gonna download the latest LemLib zip and see how big it is. Sorry, this is a bit of a tangent, but I'm curious. How much memory do we actually have left to deal with? Because depending on that, we might actually they might actually want me to yeah, see, the zip file itself is 20.6 megs. So let's extract this and see how big the binary is, because that binary will be uploaded to the V5. Holy we're almost maxing out the memory of the almost maxing out the storage of the V5. You know what? This is actually unacceptable. We have to fix this like now. Andrew makes a good point here, but before they do that, I'm gonna have to do stuff here. Hello, Cohen. Okay. You guys can unmic if you want. If you don't, it's fine. So yeah, so it turns out the V5 only has 32 megs of flash memory. LemLib is 20 megs. Pros is 6 megs. So I'm not 100% sure how it would work with the statically linked stuff. I don't know if like lib pros is actually included in the LemLib binary or not. I don't think it is, because then the linker would have a meltdown. But yeah, if that's true, that means 26 megabytes is what's being used by LemLib and the Pros kernel out of 32 megabytes on the V5, and then as well, and then there's VexOS and the Vex SDK that's on there as well. So user code needs to be like tiny, otherwise running out of flash is a real possibility. At least if we do figure out linked time optimization, or LTO for short, it can very easily be applied to v0.5 once we have the actual optimization and the make file sorted, as well as v0.6. So we could actually just release v0.5.5, which has the cold package be tiny. Let's see what Andrew has to say. I'll respond to him here. There's not a better way to do it so that it's the same object for most users, but can be held in different objects. Well, yeah, but it's not gonna be nice. Like, it's just gonna bloat the API. And well, it's going to bloat the API, and to be honest, not having them separate is only, well, only adds a little bit of a foot gun. A small foot gun. A small foot gun. Yeah. Actually, no, not even, because you'll be interacting with the abstractions, not the like motor object itself. And if we have software configuration for the encoder anyway, that would mean that the encoder objects, different encoder objects, are entirely separate from each other. So they won't, if you configure one, it won't even change the configuration of the other. So there actually is no reason for us to use this. It doesn't even add a foot gun. For us, at least. Well, I guess technically there still is, but like, we're not gonna do that. We're not gonna have to deal with that because we're just gonna deal with the abstractions anyway. Now, users, on the other hand, that adds a tiny bit of a foot gun for them if they decide they want to use the LemLib hardware stuff for their own projects, for their own project API. Or if they want to use the abstractions, if they use the abstractions too, it'll be fine. But if they actually interact directly with the objects, it might add a little bit of a foot gun. And basically, what might happen is they might take it. They might want to use the motor group or motor as an encoder, and then they might accidentally like tell the motor to move or something. But like that's, or like configure the motor. But I mean, that's such an edge case, and I don't really think it matters. So a user could write their own smart motor to use a motor and rotation sensor. Well, I don't know why they do that, because then they just use it as a tracking wheel. Making an artificially large cold package and testing that. Hold on, let's see how big the cold package is for a project. Because maybe it gets shrunk down or something. Okay. Alright, this is like 13 megs. No, actually no, that's the ELF. That's the ELF file. Oh. No, that cannot be right. Because in the hot pack, it should be called... No, wait, hold on. No, hot pack is only like 4 kilobytes. Okay, never mind. Crisis averted. I wonder why that is. Anyway, it turns out we do not have to worry about that anymore. I mean, well, the issue is still open, but this should ideally be done pro side and not our side. Because I do not want to run a custom make file. That would suck. The pros make file is like actually unreadable garbage. Like, what is this? What's happening here? This is some... Yeah. I don't want to deal with that. So this struct is updated every time the user uses a configuration function. Every time a fit configuration function is used, rather. Okay, so yeah. An additional context. This is done to an extent by VexOS, but this is limited to mod cartridge. Mod cartridge and reverse and reversal. I don't think it's cart limits either, which would be annoying for Vexy teams. So by an extent, to an extent above XOS, but this is similar condition and reversal. Ideally, this would happen. This would be handled by the XOS entirely. But we can't control what's in the XOS. Ideally, this would be handled by the XOS, but it's unlikely that this would ever get implemented into the XOS. Alright, I'm gonna ping Rocky and Rocky for this. Sorry. I live in college dorm, so that means people make noise. Okay. All right, let's see. Which one of these people can I ping? Benny does CLI stuff. I think actually no. I'm just gonna ping pros. Actually, nope, I cannot. How unfortunate. Abstract module class? There is no abstract module. Wait, what does elephant mean with this? Hold on, give me one moment. Alright, sorry, I'm back. Let me see if the mic's still working. Yep, the mic is still working. Oh, okay, let's see what's up with this. Okay. Alright, it looks like Nick let's look at this as well. Alright. Yeah, limitations. Actually, I'm not gonna write that issue request because I already opened it on pros and it needs to be handled by pros. I'd rather implement it into pros myself than having to implement it in hardware because it's gonna be way harder and limited if I implement it in hardware. Okay, looks like VS Code is losing its mind. I'm just gonna reload the window. You know what? While I'm here, I'm also going to open an issue for this, for the settings here, because if you tell pros not, it doesn't matter if this is selected or not. It'll always open, and it's super annoying. So yeah, let's get that open real quick too, while I'm in the mood to actually open it. Okay. It should be Vex, Pros VST, yes. Let's see if it's already in a show for it. Nothing works on ARM Windows, that's fun. This is like a critical issue. Why aren't they doing stuff about this? Platform 5. Yeah. Used on Windows 11, x86. Arch Linux. And Debian-based Linux. Yeah, I haven't tried it on any other distros yet. Start page. Sorry, disable welcome page. Disable welcome page. Reload window. Observe welcome page. Yeah, I am streaming alone in the call. Because I'm also streaming to YouTube. And if people want to talk with me while I'm streaming, that's possible because I can join the call. Alright, now we can actually get back to hardware. That was a bit of a tangent, but yeah. Okay, change motor group output velocity and software motor offsets. Let's do the software motor offsets first. Because that's going to be harder, and also output velocity might also mess a little with like the angle stuff, so it's best to use software motor offsets first. Alright, software motor offsets, we'll do that motor side. I don't think we'll have to change anything motor group side, but I'll double check after. So the advantage of software motor offsets, I think I explained it before, but basically it means that we can set the angle of a motor to a very specific angle instead of just like the nearest encoder tick. And it also means that if we have two motor objects on the same port, we can change the offset, we can change the angle of one object without affecting the angle of the other object, and that's super nice and prevents a lot of bugs, or potential bugs at least. And it's always great when it's harder to make a mistake. So, okay, get absolute counts. We won't need this anymore because we don't need the relative motor counts anymore. We just get the absolute motor counts now. And now it's going to be very unhappy. Or no, it's just one bug. It's just one error. Okay. Motor encoder ticks. That would be an integer. But we won't actually. We want an offset, which will just be an angle. And by default, this will be just 0 SD-bag. Hold on, this isn't actually. I'm just going to rearrange this just a little bit. This should be at the top. Really makes me want to make my own formatting project that can actually format stuff well with more options. Okay, so motor move, we do not care. Move velocity also isn't affected by this. Get angle is affected, set angle is affected, get type's not affected, get cartridge is not affected, this isn't affected, now this is affected, so none of this is affected. It's only these two that are affected. So let's just give ourselves some space here. And yeah. Let's get to it. Okay, so let's see. Let's do a little bit of brainstorming. So, motor, roll motor position is the number of ticks measured by the encoder. It's the number of ticks measured by the encoder. This can't be changed by software, only by rotating the physical encoder, which means objects, encoder objects, configurations. Actually, I'm not going to write this stuff down because it doesn't actually help us write this. Actually, we'll do set angle first, because that then we have, well, it'll be easy to do get angle after we do that. Angle parameter is the what we want the motor, or actually no, we'll just rewrite. So angle, or we'll rename it set angle equals roll position plus offset, and we want to find offset. So that means set offset equals set angle minus roll position. Why am I using snake case? Oh yeah, I was working on the Vexy team's Queen code base, and they use snake case, so I kind of just got too used to that, I guess. Might actually switch to snake case for v0.6. Not sure yet. We'll have to see. Did Andrew have anything to say? Oh wait. No, Andrew did not have anything to say. Alright, so I guess the first step here is we need to get the row position. I think that's an integer. Sorry, what was that? So the row position is the number of ticks measured by the motor encoder, and it's not affected by any software configuration. So basically you can't change that, and the reason that's useful is because then we can have two encoder objects, each using the same physical encoder, but we can set the angle of one without it affecting the other, which prevents potential bugs. Does that answer your question? Okay. Right, so I have to make this PR into Pro. So this has a default value of null, because having to pass null every time is so annoying. Okay, so we have okay, now we have the row position, but this gets, and this is it a float? No, it's an int. Okay. Row encoder, okay, gets the row encoder count of the motor at a given timestamp. Okay. So now we have the row position, but we need to consider the motor cartridge, so we can convert that into an angle. So we already have code for that here. Let me just check if this is that's the 32-bit int max and not the 64-bit int max, because yeah. Yep, that's a 32-bit max. Cool. Yeah, I'm just gonna move the error checking around a little bit. Okay, now we don't have to handle different units, fortunately, because row position is not affected by what encoder units are set. Because we get the row position, we get the cartridge, and now we need to convert that to an angle. I'm going to rename this to ticks instead. Okay, we have this code here. Const in TPR, ticks per rotation. Yeah, we'll want this. So then our angle would be it should just be ticks divided by ticks per rotation. I think. I'll put it in comments. It's still the morning of me. I can't think yet. Have to remember to use double instead of float. So used to using doubles instead of floats. Sorry, other way around. So used to using floats instead of doubles. Okay, let's just verify the math here. So ticks per rotation. So if you do 360 ticks equals 360 ticks per rotation. If you do 360 divided by TPR, so the measured 360 divided by TPR, which is also 360, that would be one rotation. So yes, the math checks out. And then return 0 if it is successful. Yep. Seems good to me. And now for get angle. Actually, I'll explain the benefits of this in the documentation here instead. But actually, we're gonna have to like sort this out for oh, you know what? We'll have to implement this in the motor group stuff as well, because we can't store a vector of LemLib motor objects in the motor group. So we'll have to have this motor group will have to have its own vector of offsets as well. That's annoying. And it makes it it makes the internals more complicated, but you know what? The whole point of the library is to make it easier for the user. So we will do that. Okay. This is pretty easy. We just do this. Why is it? Right, because this is an angle. We can't return max on error, we need to return infinity. There you go. That software offsets implemented for the motor. Let's just document that as well. Actually, do I even need to document that? Yeah, I think I do. We can get rid of this. So that's it for the motors. Now we have to do the same thing with the motor groups, and then we can make that commit. Oh yeah, right. Setting motor angle on this one is going to be extra fun. Or it might make it much simpler. Let's see what happens. We need to store offsets, so I would be vector of angles. Okay. First thing we want to do is do the set angle. So vector of motors. That's the same thing for the offsets. Actually, we already have the offsets, so we don't need to do that. But see, the problem here is I think get motors only returns motors that are connected. Yes, that is the case. So what that means is yeah, what that means is we could actually the offsets of vector here could actually be bigger than the motors vector that we get. So we need to figure out a way of how we can associate each offset with a motor. but I think I know how we can do that. See, all we do is in get motors here, we just use the offsets here to set the offset of the motor object that we return, and that would work that would work beautifully. Okay, if the motor is connected, but wasn't the last time we checked and configured to prevent side effects of reconnecting? Hold on. Don't add the motor if configuration. Now that doesn't make sense. So if pair. Don't add the motor if configuration. What does this mean? If configuration fails. There we go. We're gonna have to take a look at configure motor over here, because I think it sets the angle as well. Actually, no, we don't have to worry about that, because that only sets the offset. That'll set the offset and then immediately continue. It won't set the offset after it configures it. Well, not immediately at least. So actually, I'm just gonna add the to do anyway. So you can see after you got it all done. Offset stuff. So then after this, if it's still running, then we need to add the motor, and then we set offset. But to do that, we're going to need to iterate with an index instead of an object. So you have to change this out. Less clean, but it is what it is. provides access to the data contained in the percent actor. Now see, we actually changed that. We might actually change that here. Hold on. Let's see what Google says. Oh, you just access it like an array. Okay, cool. So you just test the online C++ compiler. So std pair, where is that? What header is that? Let's find out. It's the utility header. Cool. I don't know if it's gonna compile this. Let's see. If it doesn't, I'll just do it in a more verbose way that I know will work. Alright, let's see. Yep. Right. Now let's see, which one of these work? Oh, this works. Okay, I'm just gonna make it use ints instead, just kind of so I can be like absolutely sure that it works. That is, it's not just some like weird, something weird. Let's make them both 0. And then we set it to like true instead. Oh, sorry, not true, to 2 instead, rather. I'm gonna have it do different things for each one as well. Yep, all of these work. That was actually kind of cool. I was not expecting it to work like that. Okay, we're gonna have to create this motor at the start instead. Actually, no, we do that. Yeah, we have it right here. We don't actually need this. This is unnecessary. We just do this. Oh no, wait, that's a pros motor. But that's fine. We just changed it to a LemLib motor. Actually, I guess we should set the offset of the motor at the start, not the end. So over here, we don't want offsets. What we want, What is it that we want? We want this to be equal to the angle measured by the motor last cycle. Is this going to bite us in the ass? No, it won't. We're just gonna change it a little bit. So yeah, we only want to store the offset. We don't want to store the angle that the motor measured last cycle, because then bad stuff could happen. It sounds like it's gonna post bugs. Well, it just feels like it. I know it will actually. So we need to store the offsets instead. So we have to calculate the offsets ourselves. But that is done set angle, and this is get motors, so we don't worry about that yet. But what this does need though is a way to set the offset directly. So we'll have to add that functionality. This would be a pretty simple function. And it can't fail either, which is nice. Parameter offset. You know what, since we have the set offset, it only makes sense to also have a get offset. Writing this example code is so tedious, but at least once it's written, it's pretty easy to change afterwards. And in my opinion, example code is possibly the best documentation a function can have. So I wanted to set offset IAS to DAG. Okay, there we have our setter documented. Let's document the getter. Okay, now let's demonstrate that what happens when to the offset when set angle is called. Okay, there's the offset setters and getters documented. Let's implement them. Okay, so it's underneath the set angle. So it's right here. Alright, that was pretty simple. Hold on. This should be after the getter, not before. There. So there we have the offset getters and setters. Nice. Now we can continue with this. And we don't have to do error checking on this because this can't fail, because this doesn't interact with the hardware. But you know what? This configure motor, what this is going to need to do is this is going to need to set the angle of the motor by setting its offset. So we can move this to here. Okay, so there's get motors. Let's do configure motor now. This is a hell of a function here. Okay. Let's see what happens here. Alright, so Boolean success stays true, and if something bad happens, it just gets set to false. Okay. Set the motor's brake mode. Yep. Calculate the angle to set the motor to. Now this is the interesting one. And the complicated one. So let's see how this works. So angle is set at 0 degrees, and then we have this massive code block to figure out the angle. Okay. First, what it does is it finds all the working motors. Okay, so okay, so over here we have to get also take into account the offsets of the motors. So instead of doing a pros motor, we will do a LemLib motor. Also, we can't do we have to use a. We can't do this. We need a for loop. Like sorry, like a regular for loop. Okay, something we're going to need to do is we're going to need to actually no, we don't have to take the motor by reference. We can I mean, we just save its offset. Oh, you know what? Let's take a look here. So we have this check here to ensure that the motor we're configuring isn't that the motor we're trying to get here is not the motor we're configuring. We're just checking the port. Yeah, that looks good to me. Yeah, this should work fine. So over here, it gets the average angle of all the motors in the group. And over here, we've got angle. And over here, it sets the angle of the new motor. Yep, set angle. And then, but then, what needs to happen then? We need to, save the offset of that motor. So, and how we save that offset is by storing the value of the offset in the vector of offsets. So what I'm just gonna do, add a 2D here, 2D set offset or save offset. Let's see where configure motor is called. What I think we might want to do is return, have configure motor return an angle, which is the offset of the motor. Yes, let's do that. That'll be cleaner. And also just want to see where configure motor is called. It's an add motor. It's in get motors. Yes, so it's in configure motor and in it's in add motor and get motor. So add motor is where it actually adds the motor. Yeah, so we have its return angle instead. You know what? I think having a vector is a separate vector is a bad idea for M offsets because we already have this here, M motors. So we'll just, instead of using a pair, we could use a triple, or I think we may want to use struct for this one. But I don't want anyone else to have access to that struct though. Let's just use a triple instead. Actually, hold on, I just want to see how a subclass works. C++. Nested class. Okay, yeah, we'll want to struct. Alright, it's been a while since I've done this particular thing with structs where we can have like a struct as a type. I just want to see if we need to type def it or not. Hold on, I'm just gonna do what we do in LemLib. Hold on, one moment. Alright, I'm back. Let's take a look. Oh, I got a lot of pings here. Oh, what's up? Oh, okay. Tropical says this is just not the case. With like the motor disconnect thing. Oh, yeah, right. We want to see how we do the structs thing in LemLib. Stable branch. Alright, we just do it like that. Motor info, yeah, that's what we call it. Import bool connected last cycle and angle offset. All right, cool. And then for this, do std vector motor info instead. So it also contains the offset of each motor. Needs to be, this needs to be saved by the motor group. Because the offset is lost every time is lost because the offset is lost because it can't be saved in a motor object. Motor object as motor objects are not saved as member variables. Hello. Who am I saying hi to? Hello. Yeah, I'm just working on more hardware abstractions. It's really a pain to work with, mostly because the Pros motor doesn't have. The Pros motor. The copy constructor of a Pros motor is implicitly deleted, which makes my life a lot harder with motor groups and adding and removing motors dynamically. Yeah. I don't think they even needed an abstract motor is a thing. I'm not implementing an abstract motor. Motor groups and motors is fine. If you want to deal with one motor or potentially multiple motors, then use a motor group. You don't have to use a motor and a motor group, because that means the regular motor API is really, well, it has so much duplicate code in it, and it's got parameters that aren't used. Yeah. Yeah. Yep. Well, basically, the hardware abstractions basically make the API super nice, but it still has to deal with the not nice API of pros. So, yeah. Yeah. Nice. I haven't really told anyone in the public space about that yet, because I know people are gonna get super excited about that. Yeah. Oh yeah, yeah. Oh no. I let people know in some of the other alliances I'm in. I mean, your code's already on GitHub, right? So, I mean, the cat's out of the bag. Yeah. Yeah, I basically just let people know to stock off on distance sensors. Um, because depending, I have no idea how widely used it's gonna be, or how widely used LemLib is, because like we have no like telemetry. So I don't know if it's just gonna be like 50 teams that use it, or if it's gonna be like 1,000. Yeah, yeah. Yeah, we tried like LemLib. We tried to make our own like package manager thingy, but we just didn't have the manpower to actually do it. We have to wait for branch line, unfortunately. Or what we're doing before branch line's releasing is we're just bundling all the dependencies in the template. Right. Yeah, I used to use flows for everything, but now I'm switching over to doubles because um, people are not going to benefit from the added speed of 32-bit floats, but they might benefit just ever so slightly from the higher the higher precision of doubles. Yeah, right. That is true. Yeah. Nice. Oops. Well, oh yeah, I guess you can make that decision. It might be better to what might be actually I don't even know how you'd do this, but maybe if you could release data on like how much of a difference there is just regular odom and with a particle filter, that might be useful. But then it's not as useful without ground truth. Yep, nice. Nice. Right. Yeah, I guess that is true. But if people who don't really know how odom works are messing around with particle filter, like that's kind of on them. Yep. 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 Oh, that drew, right, SparkFun drew, yeah. Right. Right. Yeah, TNTN has been having a great success with that SparkFun sensor. Yep. I got like a sample from SparkFun, for free, so I could implement it in LemLib, right? But so what I did was I gave it to TNTN under the condition that they do a lot of tests on it, and also one of the committee members of LemLib are on TNTN, Cooper, and when the time comes, Cooper will write the implementation for it in LemLib. Cooper's also designing a module for it to allow it to interface with the V5 brain. He's got a prototype right now, but still needs a bit of polishing. And he's also writing a driver for it for the V5. No, it's okay. I don't need one to test. I got Cooper to test it for me. His stuff works. It just needs a little bit better error handling. Nice. Yeah, that's how I did live data as well with the 0 to W. I want to make like a wireless module for the V5. That's just like an STM32, and then yeah. Yeah. Yeah, that's what I want to do with my wireless module. Because you can also upload code through a smart port, I just need to reverse engineer the protocol between the controller and the brain over a wire. Yeah, I'm gonna take a look at it, and also I have two ways I can figure out how it works. I can either like listen to the packets that are being sent, or I can decompile VexOS and see what's going on. Index motor stable. For what? Yeah. Yeah, any persistent data that we need on the motors, for the motor group, we store in like a vector of structs. And then every time we want to interface with the motor group, we just create a vector of LemLib motors so we can interface it with it easily. It's a whole thing. Yeah. Yeah. Don't worry. Yeah. Don't worry. This interface, it kicks ass. Okay. You should consider using it. You should consider using it. That is true. You already have a whole thing set up. The only reason I'm doing this is because I'm rewriting everything anyway, and this makes it easier to write. One thing I like about this is that move isn't voltage based, it's based from -1 to 1, which means it can properly scale voltage for 11 watt motors and 5.5 watt motors. Yeah. 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 Mm. I've been working, yeah. I think I already told you about my work with the Queen's swerve drive, right? Alright, I was working on desaturating the motors desaturating the motors for it, because they didn't desaturate the motors for it last year, which means they had to have the top speed of the drive at Worlds. And that's not ideal. But yeah, I mean, but it's just like it's hard to do as well, because you have to consider like the potential outputs of PIDs, and that makes it a lot more complicated to implement code wise. And then because it's like omni wheel swerve, and they can take advantage of XDrive kinematics, it means that you could change the outputs of the wheels, or say the angles of the wheels. So you could get an output. So your desaturation output could be could have like a lot of valid solutions, but you'll have to find which one is the most optimal. And I don't think it's a closed form solution to do that. Yeah, so we'll need a heuristic approach to actually solve this one optimally, at least. I can get a working solution out pretty easily, but if you want an optimal one, it's gonna take a lot more effort. So I'm just gonna hope that my approach is good enough for now. So we can, yeah. I need to refactor like a lot of their code, because it was all written at like 5 a.m. and didn't really document any of it or structure it well. Yeah, I can't believe they made that all super late. I mean, but I guess it worked, even if it was a bit scuffed. What are you trying to automate? Yeah. All right. Sorry, what was that? Oh, yeah. It is, yes. Wait, what do you mean underactuated? Right. Yeah. Yes. Yeah. We kind of do that. So one of the benefits of having Omni wheels on the Swerve drive is that unless every single one of your wheels is perpendicular to where you want to the direction you want to accelerate in, you can accelerate in any direction instantly. And yeah, so then we kind of do that. It's not as fancy as making sure the wheels don't slip or maintaining the energy, but it would be pretty similar. Yeah. But, I mean, Swerve drive kinematics on their own, even for differential drive, is pretty simple. So I think optimizations like that would actually help make a difference. Oh yeah, right. Yeah. All right, nice. Right. Right. All right, hopefully. Well, okay, I almost got the software offset done now. in terms of for the motor group. I actually just need to check my schedule to see how long I can keep on working on this. I think I'll have to stop in around 15 minutes. I mean, not really. I gotta go eat lunch. All right, it's 1:15 for me. Well, about 1:16, I guess. Oh yeah, you said you're going through Frankfurt? So where are you right now? Huh. So what are you doing in Frankfurt? Don't you have school? All right. 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 Yeah. Nice. Yep. Hey, you'll be fine. Okay. Yeah, that's hardware offsets software offsets for motors. Nice. Yeah, without software offsets, if you try to set the angle of the motor, it's just gonna round down to the nearest encoder tick, right? But with software offsets, it'll be exactly what you want it to be. Yeah. It's also nice. What's nice is gonna have like two encoder objects that have the same motor. So they both have motor on port 1. So you can change the angle of one without changing the angle of the other. That's pretty nice. Yep. And even if you try to set the angle with like the Pros API, it still won't change the angle of like the LemLib motor. Which means it's basically bulletproof to anything the user can do. Actually, no, it literally is bulletproof. There's no configuration the user can do to break it. They can't change encoder units. They can't change angle. Neither of those would break it. Okay. So that's software offsets for the motors. Let me check what we have for the encoders. I don't think we have software offsets with encoders. Okay, so we already do that for the ADI encoder because of limitations of XOS. Or the XSDK rather. Let's see. I don't think we do the same for... No, we use hardware offsets for the rotation sensor. Okay, but the rotation sensor stuff is super simple, so it'll be fine. Hold on, why is my tab button not working? Hold on, I'm just gonna reload the window. We have a automation for depot that you can use. Oh, because it's... Did you add a template? Did you add a template zip to the release? Okay. Oh. Oh, do you have a depot branch? Because you need a deep. Alright. Yeah, you might. Okay. Alright. Yeah. Yeah, for sure. I don't like doing that because it ruins the commit history. I mean, I don't really care about that too much. I mean, my contribution graph is like pretty gray for like the last couple of weeks. And Queens uses GitLab, which means I don't get my contribution stuff doesn't carry over. The UI is a bit, UI isn't quite as nice, but what's really nice about GitLab is the code review. And just how it handles like pull requests and issues is a lot nicer. And you still get all the automation stuff. But yeah, UI isn't as nice. Are you going? Okay. Yeah, see ya. This is the popping and locking theme. Oh, I don't know. I didn't realize you joined the VC. How long have you been here? Oh, okay. Alex just left. Alright. Yeah, it is quite nice. And it works really well with CLangD. Yeah, software offsets now. And then I think it's done after this. Let me see. Okay, it's very almost done. Like this is gonna take like 5 minutes to implement. This is like gonna be done in 5 minutes as well. Basically, software offsets mean that the offset of a motor. Actually, no, I'm not gonna explain all of it because I already explained it like 500 times in this stream. But basically, it just makes it even nicer. Yeah, and then after about 10 minutes, hardware should be done. I'll have to hardware test it all again, but I already got the hardware. I already know it works the last version, and the changes I've made isn't like huge, so it's pretty good chance it's still gonna work. But yeah, at least the API is not gonna change, which means I can start working on Odom. Are you doing a PTO? Oh, that's interesting that you're doing a PTO on VexU. Usually people just like add more motors. Cause like, well, yeah, and don't, because like I'm streaming to YouTube right now, so don't say anything. Don't leak anything right now. On chip? Yeah, on chip's fine. I'm having a lot of fun working on the Queen Swerve Drive stuff. Did you know that if you have Omni Swerve, right? You can move in any direction instantly, and it doesn't matter what angle the motors are. Sorry, what angle the wheels are facing. So you could have something. you could have like the wackiest like wheel angles, but you'll always be able to accelerate in any direction instantly, which is like super nice. Yes, unless they're all perpendicular to the direction in which you want to accelerate in. Yes, it will. They also don't really have many motion algorithms for it yet, because they've been mostly focusing on like the actual control of the drivetrain, which means I'm going to be implementing all of that stuff. So I'm not gonna go fully optimize stuff yet because Nick's still working on that. And his papers on that, I think. So what I'm gonna do is I'm just gonna do what I do with the regular swerve drive, and that is create a motion profile, have a distance parameterized, and then just have a PID on X, a PID on Y, and a PID on theta. Yeah. No, it's still a velocity profile. And then but then feedback is just 3 PID loops. So yeah, it's really simple. Control path following or just motion in general with the swerve drive is way easier than with differential drive. Yep, and you can have it face whatever angle you want, and it doesn't matter. Although it does make generating the path a little bit harder. I might have to. I'm probably gonna have to talk with Jerry and see what we can get sorted in path.jerry.io, because I'd love to be able to use path.jerry.io for our swerve stuff. I don't know. I hate making UIs. Yeah. I wrote the previous LemLib path generator in JavaScript and HTML and stuff. It works, but it's very basic and it doesn't look nice. So Poro's got Poro's recently updated the SDK so that they can finally implement the AI vision sensor. Yeah, James decided to actually update it finally. Although he did not do what he said. Yeah, but he did not do what he said, and he did not add a SDK function to get the type of the motor. So the only way to differentiate between the two of them is to like do the cartridge trick or use the like the cursed function pointer thing. Yeah, there's not anything wrong with it. Yeah, that is quite strange. You should get Cooper to make you like a wireless module so you can have a proper terminal. Right. Yeah, what I want to do is I want to make this wireless module. It's just an STM32, and so then you just plug it into a smart port, and then if I can reverse engineer the wired protocol between the controller and the brain, you'd also be able to upload programs through the smart port. So it literally, because you're gonna have to connect to the smart port anyway, right? Yes. So why do both when you can just use one? Oh yeah, you can do it right now. Yeah, last time I tried it didn't work, but I just had 2 people try it and both confirmed that it does actually work. So I think it might have just been like I got something wrong with the controller. Okay, I think that should be software offsets for everything. Hello, Jamie. Oh yeah, what do you think of Alex's particle filter thing? Yeah. I really think it could I really think it's gonna change. It's gonna be a game changer. I really hope it is. Because finally, yeah. You can use one distance sensor, but it's better with multiple because then you got more data. It's basically poor man's LiDAR. Actually, I wonder how hard it would be yeah, I wonder how hard that code would be how hard it would be to adapt that code to work with LiDAR. I don't think it will be because this yeah. Yeah, no, but it's because he uses the Pros LabM, which is literally 300 times slower than the soft FP LibM that they use in Vexside, and that you can literally just swap out the LibM and then boom, it zooms, or you can PR that to Pros, and then you can get even faster with a hard LibM, but that's gonna take a little bit more effort to do. What you could also do is you could actually use neon instructions with soft floating points, and I think you might actually be able to get even faster than full hardware floating points then, because then you can compute like a lot of floats at once. So yeah, I don't really think it's going to be an issue, but I do know that Queens has issues with performance even with soft FP. Like the ABI compatible hardware floating point stuff. They had to they're switching to a simplified Kalman filter now for performance reasons. Okay, so then only thing left is change motor group output velocity. Right, this is actually not going to be quite as simple as I thought it would be. Still not going to be too bad, but I do have to go, unfortunately.